Hello everyone, Caroline, founder of Bubbly Maths and co-founder of the G10 Global Teacher Empowerment Network. Today it's Mindset Monday, and today on my own, getting in. Today I'm going to dedicate Mindset Monday to something that's very close to my heart. I talked about this before, and that overcome problems with maths and maths anxiety, struggling with maths, just becoming a better achiever in maths. In my life, I dedicate my life to maths. I dedicate my life to helping. My mission is that every child on earth will love learning and enjoy mathematics. And people introduced me as, here's Caroline, the maths genius. And I'm like, no. I am no maths genius. My experience with maths is that I make constant mistakes. You know, those silly mistakes, your teachers, wherever, there was always someone in class who made silly mistakes. That's me. I am the ultimate silly mistake maker. And it's because I see one thing and think another, or think one thing and say another, or write another, or whatever. But they talk about read the question. It's all there in the question. But I read the question, and it isn't all there. It's like jumbled up, or I'm blind to certain things on there. Now, why did that not? You'd think that would cause me to become a nervous wreck, someone who hated maths because I didn't read, because I got it wrong all the time. The same happened in English comprehension, by the way. I've had to read a question and answer it, I'd answer the wrong question because I'd misread it and things had got jumbled up. And yet, I managed to get really good marks in what is now in England the GCSE, the exam that you take when you're 16. And why is that? I managed to get a degree in electronic engineering, which you cannot do without mathematics. And why? What was the difference between me and other people that have the same problem as me, struggle with maths with me, get it wrong like I do, and yet they give up, yet they become anxious about maths, they hate maths, whatever, all the negative things, and they fail at maths. Well, the difference that I worked out is that I enjoy it. I enjoy the process. I enjoy the puzzle. I'm quite happy to work on the same puzzle for days and days on end until I finally solve it. And then I've solved it. And then the next day I look at it again and go, oh, I've forgotten how I did it now. And then have to go and do it again. If I do it enough times, then I've got it, unless I leave it for a few years. But the more times I do it, the more readily I get it. The point being that I enjoy the process. That is the key, enjoying the process. So what is the key to a growth mindset versus what they call the wonderful Carol Dweck calls a fixed mindset? And that is the growth. The growth mindset requires enjoyment. It requires, a lot of us have perseverance and determination. We don't necessarily apply it to the things that we don't want to do. And how do you convert something that you don't want to do into something you do want to do is enjoyment. And how the best way to create enjoyment out of a subject or something that you don't want to do is to put music to it, dance to it, or make it a game. So gamify it. And that is what my colleague Tony is really, really good at. She, at 5 o'clock in 55 minutes, we'll be doing the Happy Maths Hour. Now, today, the Happy Maths Hour is all about Escher. It was last week, and we're doing, Escher's got so much that he did. And he wasn't a mathematician. He was an architect, I believe. And he was an amazing artist. And and we're going to be looking at a lot of his work. In fact, I'm just going to share the screen for a moment and just see what happens. I'm going to just put here, there you go. That's what we're going to be doing at 5 o'clock. We're going to be looking at, this is mcescher.com. That says visit our shop. Don't know what else we can do if we click on there, what other wonderful things of Escher's that we see. That is one of the most extraordinary paintings, drawings that Escher's done, and we're going to see a lot more of about that at 5 o'clock, about Escher's life. Right, so what we're going to do now is, I don't know, I am not a sophisticated person. Nothing sophisticated about me. The best way I can help you understand anything, and I just realized I haven't set up the visualizer, is by doing it. So I've got a few examples, a few resources here. I've just got to unhook. I don't have a spare slot here. So I've got to undo what I was doing there, close that down. And I'm also going to share. I don't have anyone out there to share for me. So I've also got to share. I think I've got that done. I just have to remove my external hard drive so that I don't accidentally make it useless. And plug in my visualizer. Here we go. There we are. I'm also going to share what we're doing on, here we go, on the Bubbly Maths Facebook page. Now, as of next week, I'm pleased to say that we should be where is it? It's here somewhere. Next week we should be broadcasting on all of the channels. We managed to, I'm not seeing it here. I'm not seeing this broadcast. Oh, that's because it's not on this. So I think it's already on there, so I don't have to share it. It's all good. I tell you what I do need to do though, is share it on my personal page, so that there are some people that follow me on my personal page that definitely want to see it. And as of next week, hopefully, we'll be automatically sharing it on all of that from the get-go, which is wonderful. And hopefully the lovely Yvette will be with me next week. And you just move your finger ever so slightly too brusquely, and it's gone. It's all gone. Okay, let's start again. Facebook.com. Facebook.com/Bubbly Maths. Now, don't press anything else. Don't touch anything. Don't touch anything. And we will get to, now if I'm very gentle, very careful, it won't take me somewhere I don't want to be. Okay, so far so good. And that's not me, that's a couple of weeks ago with Yvette. Some wonderful pictures, and here I am. So I can now share that with my profile. Fingers crossed. My profile, fingers crossed, fingers crossed, fingers crossed. Oh, right, now, share. Okay, I think it's done it. By George, she's done it. Oh no, I've shared it to my story. Here we go again. That's what you get when you're, what I was talking about. Reading, shared to my profile. Right, okay, that's done. Whew. So now I'm going to go back to good old StreamYard, which is where it all was broadcast from. And I'm going to change the camera. And to change the camera, we're very lucky. Here we go to the visualizer. Beep, 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 beep. So what is the key to overcoming anxiety when it comes to maths? What is the key? How do you help people remember? This is something we've been doing during this week, the course of this week. Tony and I have done a couple of workshops in the last week, and this helps you remember, understand and remember how to do the area of a triangle. Now, most of us have to learn how to do the area of a triangle, and this is how we'd use this in all different age groups. So I'm going to, no, I'm not going to do any jiggery pokery, I think. Well, that's on there. I could maybe do jiggery pokery. Okay, I'm going to do jiggery pokery. So the jiggery pokery is going to be that I'm going to put on the name of this activity, the link to it. Now it's trifold. It's called trifold. I'm going to put that on the bottom. It's not in the description, but what you will find in the description is a link to the Aiming High website, so you can just search for trifold on there. But I'm going to put in this link here on the StreamYard so that you can go to it. Now create a banner, scroll across the bottom, add banner, and show. So this is the activity that I'm doing here. Now, this is something you do. You might learn the area of a triangle in late primary, but mostly, I don't know, when you're 12, 13. So we don't start here. We start by taking any triangle, a young child of any age at all, any triangle, and just, I mean, you literally cut out several triangles for a young learner and then give it to them to play with. Now, if they're at the age where they're just putting everything in their mouth, that's too young for triangles. For that, you'd want to give them solid triangles just to have the experience of shapes. So you give them shapes to play with that they can do whatever they want with. In the case of my grandson, he would like to build towers and destroy them with any shape that you gave him. And then he became more constructive as he got older. In this case, once they're old enough to actually play with a bit of paper, you can maybe give them cardboard, is just fold it. Just make a fold. So you start with a triangle, and you can look, it's got, you don't have even, this is free play. So it's just give them a triangle, fold it. Now what have you got? Oh, well, actually, you could look at the shape that you've got. It could be a sailing ship. It could be, well, how many triangles have you got? We've got one triangle there. Is that a triangle? And you can look at that, but you don't even have to have that conversation. It's just like, what does it look like? What shape have you got? We'll just literally just let them play, let them paint, let them stick on things. Just have a play with triangles. You can do the same with all the other shapes. You can play with rectangles, with squares. And now you can mention the name of them. And if you're not sure what they are, use the Aiming High, well, just Google it, or use the Aiming High activities. So this is what you do for the younger learners once they're able to manipulate paper. Just play, free play. As they get a bit older, you can talk about the names. Like, okay, so this shape here we've created, what can we call that? Well, a great way to know what to call it is just how many edges has it got? It's got 1, 2, 3, 4. That's an edge there. So it's got 4 edges. Is it a square? Is it a triangle? Is it all the different things you could think it could be? But there's a general name for it. It's a quadrilateral. And then you can put all these shapes together, do some painting, create a poster. You can create a poster naming the shapes that you've made. And you can also create a poster just colouring them in so that you are seeing the shapes that you've made on just put it on the wall. And that's a reminder as children are getting a bit older. And then the next level, these same games, and it's in the trifold activity that's flashing at the bottom of the screen. The next activity is, okay, now how can we take a triangle? This is specifically to be done with a triangle. You can do it with other shapes as well. How can we make a rectangle? So a rectangle, to make a rectangle, we have to be sure that that line is parallel to this one, of course. So find out how to do that. You can make a rectangle simply by folding these over, and hey presto, we've got a rectangle. Now what's special about a rectangle? It's got right angles, all four angles are right angles. It's got two equal parallel lines. Here's another two equal parallel lines, and that's a rectangle. So I've made a rectangle. What about a square? I tell you what, Tony managed to make a square, and I'm not sure if I can manage to make a square. So we've got a square, we've got an edge there. Now for a square, you have to think about what the properties of a square are. That needs to fold over, and that needs to be equal to that. So how can we do that? Well, if I fold that over there, then I know that that length is equal to that. So that length is equal to that length. So then if I fold that over there, then I know that this shape here is a square, more or less, close enough. And then you can think, what other shapes can I make? Well, what have I got here? I've got a trapezium. It's got two parallel lines, and the other two are not parallel. But these two are, so it is a trapezium. It's not a regular trapezium. It's not a symmetrical trapezium. All these words are words that you can simply talk about and enjoy. And this is not a lesson. This is just play. And again, take these shapes and stick them on the wall. And the satisfaction that you can get from creating these shapes. What other shapes can you make? How many different ways can you make a rectangle? What different size and shape? Not shape rectangles exactly, but what different proportion rectangles can you make? Can you do this with any triangle? And you can just all sit around the table and do it together. And I enjoy doing this process. So, and if you're not sure about the vocabulary, just look in the trifold. Now, going back to this is Mindset Monday. I'm just going to remove that for a moment. Whoopsie. That didn't, we'll remove it. That didn't, oh, I know, I've got to change the camera. Hello, I'm back. So Mindset Monday, what have we talked about so far? We're looking at I'm going to make my list, my top 10 list of how to use growth mindset to enable success in the maths classroom, to remove anxiety or to reduce anxiety. It's a process. You have to do it a little bit at a time. And so what we've covered so far is play games. Play games. No pressure. Pressure isn't to learn. The pressure there is no pressure to learn, no pressure. There is pressure, of course, at some point during your maths career, but for someone who's experiencing maths anxiety, pressure doesn't help. And in order to go from having maths anxiety to having a growth mindset, you have to take the pressure away. And then I nurture what I call, just normal names, but I use the term perseverance and determination. So now the good thing about perseverance and determination is if you work with your learner and every time they say, I don't know, if you've got, I don't know, I can't do that, and they walk away, if you praise perseverance and determination and you praise the effort and you praise, I'm going to say praise hard work, praise effort. So the research by the amazing Carol Dweck is that what you want to do, I'm just going to write that in the ticker date to create a banner, ticker date. Carol Dweck, and the book she wrote is called Mindset. So if you're inclined to do things like that, Mindset is a fantastic. If you want to read a book, you can listen to it on Audible, you can buy the book, whichever you prefer, get it from the library. What Carol's research, she's a psychologist at Stanford University, and her research has shown that if you, and this applies to people that go, say, to Cambridge University, this applies to athletes, this applies to executives, of high-end executives, and it's basically the high achievers. Let's look at the high achievers just for a moment. The high achievers, for example, might be someone who's gone to school and always does well and is the top of their school, top of their class, top of their school. And then they go and they make it to Cambridge University. And then suddenly they're not top of their class anymore because they are surrounded by other high achievers and they're not the highest achiever. Now, something very common that happens there is that they quit, that they stop, and they lose, basically because they lose confidence. Their confidence just takes a dive because they have been nurtured, and if nurtured is even the right word, they have been fed on praise for their ability, praise for their gift of being the best in school. They've just been praised, and it might have never occurred to them that they might not be the best everywhere they go. So when they're not the best, then it can be a major downer. Like, for example, they can, when you get to university level, you're studying a subject and all of a sudden it's actually, oh my goodness, I've always found this subject easy and now it's difficult. Maybe I'm stupid, maybe I'm not good enough, maybe I'm not clever enough, I'm not as clever as these people around me, whereas they're all struggling too, because you're a high achiever, you've reached it, you want to be pushed higher, and that's the desire you want to instill in your learners. That's what grows a growth mindset, is that desire to always do better. And also praising on effort rather than skill or talent. Talent is the word I was looking for. If you're praising on effort rather than talent, or written effort there, instead of, I'll say rather than talent, so I remember the word, then what you get is the learner, the adult, by the time they get into university, isn't relying on your praise or external praise to achieve. If you're praising them for their effort, then it's like, okay, it's my effort that's getting me here. It's my perseverance, my determination, and I've got it because I know I've got it because I've been using it my whole life, and I've been praised for having perseverance and determination. I've been praised for my effort, so I know that's the thing I need to be doing. So now the other two scenarios I mentioned were, I mentioned CEOs, and I mentioned like leaders of companies, I mentioned athletes, same sort of thing. There have been situations where companies have gone skyrocketed up, but then when they can plateau, and this is what happened with Cambridge University students, this would happen with athletes. They've done really, really, really well until they reach a point where they don't want to take risks as well, because they don't want to be not seen as the best. They don't want to be not recognized as the best. And so they might not want to take risks. They might not want to stretch themselves. And that can hold people back. So the point being, you praise the effort. What you're doing is you're creating you're nurturing someone who is an independent learner. So that's once that it does want to be an outcome. If you have someone who is an independent learner, then even if someone who's an independent learner who is happy to persevere, who's happy to not be able to do something and learn how to do it, who's happy to ask for advice, who's happy to go to their tutor, who's happy to do research, who's happy to brainstorm with their colleagues, and is not ashamed. That's super important, is not be ashamed of not knowing. Number one, not knowing. And number two, not knowing, writing that down. And number two, or A and B, is looking stupid. Not wanting to look stupid is one of the biggest deterrents. And I suppose it's not so much when you write an exam. I don't know, that's not my experience, but that might be other people's experience, being afraid to write down an answer in case it's wrong. That's not ideal by a long shot. So it's, I mean, obviously you want to get it right in an exam situation, but I certainly know in a classroom situation or a boardroom situation or a meeting at work or anything like that, if you don't understand what's happening, the best thing is to address that and find and get it clarified. Whereas if you're afraid of looking foolish and you don't ask and then you don't understand, things can go wrong. That's how assumptions are made. That's how things can go drastically wrong. You hear about things on the news, how, I don't know, a company went bust because they did something terribly, the finances all went skew-if, and it might just be for somebody, not on necessarily one occasion, but the point is it's really important to be happy, be confident enough to ask questions when you don't understand. Super important. So I'm going to actually, it's not ashamed to not know, and it's really, really important, and that goes for teachers that are learning, it goes for students that are learning, it goes for someone in a boardroom where they have to make a decision. It even goes for when we're voting for our politicians. What about houses of parliament? What about your government? If there are people that are voting for something that's been proposed to them and they don't actually understand it because they haven't asked, then they might make a vote that is not the one they intended to make. So not ashamed to not know, and not ashamed to ask, not afraid to ask. Now, I'm just going to show you a few of these. We've got one of these activities. We've got as far as about age 8 or so with this. And then going beyond age 8, we can start looking at symmetry. So I've got, this is something you can do with the younger learners too, is just colour in the different. So you've folded it there, folded it there. You've got these different shapes, you colour them. Oh, might help if you can see what I'm doing. So here's the nice coloured in one. And so if you find the different shapes, colour them in. That's what you can do with the younger learners. And as they get older, we can use that same triangle to look at the shapes that we've got. And this is part of the working out how to work out the area of a triangle where you can actually see it. And we've used the colouring in process as well here. So that this is a rectangle, and the area is twice the area of a rectangle. And you can actually see it because you fold these in. The folds have got to be in the right place, and that's part of the process. That's all in the, I can put that back in, that one there, that's in that activity. But you can see we've also found the symmetries. So we found symmetrical shapes. We've actually named them. These two type triangles are congruent triangles because their dimensions are exactly the same, but they're not, it's not in the same position and it's not the same way around, but every angle is the same and every length, equivalent length, is the same. And here we've got one here, that the two triangles together make a kite. These two make isosceles triangle, as do these two. But we're finding the symmetry by doing the activity. So, and then you go on to the more complicated things. You find the centers, different types of centers of the circles. There are different centers, and I didn't know that. Now I know it from having done this activity. There's different centers according to what lines you draw on them. So that's something with triangles. Then we've got these other resources. This is one of my favorite resources right here. Now, I found this. I like the color orange. There we go. I've got to get that open. And the great thing about this is for younger learners. Here we go. What you've got here is you've got, I was doing a game with numbers there, but we've got lots of beads, or whatever they are. I don't know what they are. I don't know where I found those, but I clearly found them somewhere. And you can do sorting. You can do that. They might all have to be the same. What if you had 3 in these different in the holes? You've got you've got 4 columns and 3 rows here. You can sort. You can put 2 in each. You can do counting. You can put 1 in each and count 1 to 12. You can put 2 in each and count in 2s, 3 in each, count in 3s. Or you can say, well, how many are there in this section here? And you can really do a lot of games and just use this as a way of and even as 3 times 4, you can get. And the thing is, you can use it to go higher than that. In fact, you can use it to go to any times table up to 12, because you literally put 1 in each and everything up to 12 in each. Well, maybe not 12 in each, but certainly you can go up to 12 in them, because you've got 12 holes and you can use them to just have a bit of fun. You can gamify it. You can find games that you can play with, and just use it to look at. Use it to make it real, so that if you're asking a question or if someone has to work out an answer, they're not just looking up into the air and go, oh, I'm not sure. You can actually make it very physical, and there's lots of things you can do with that, which is, I love it. And of course, it's reusable big time and very colourful and portable. Seals up, you can move it around with you. This is something, especially you can start off with younger learners. Now, the first thing I did with this, can be just used to play, although you don't want to lose the pieces. But this is a really powerful activity. Now, I didn't get the cues in there. I'm going to show you this one here. This book is from the Association for Teachers of Mathematics, and that's another resource. That's another really useful resource. Let me just pull that one on here. Oh, there it is. I'm going to. You can buy resources from the ATM, whether you remember or not. You get a discount if you remember, and it doesn't cost a lot to be a member. But the idea is there's lots of, I guess this is resources here. I'll give you that link there. And create a banner, paste that one, scroll across the bottom, add banner, and I'll put this one on for you so you can see. So that's not specifically the cues in there, but that's the website for the ATM, the Association of Teachers of Mathematics. Now, the great thing about the ATM and the aiming high, which is what Tony and I work on, and all these activities, this book is about the cues in there. This is about using. This is Q&A, and by all means get the Q&A. I'm on a budget, so I didn't get the Q&A, but please do get the Q&A. It's actually got from Italy, and it's got the same idea. And there's also this wonderful thing. There's other rods as well that you can use. There's wonderful rods out there where you can do calculations, but with these you can do. That's actually a square, a cubic centimetre. These are all actually centimetre lengths. So if we've got 2, it's 2 centimetres. And if the first thing I did with my grandson on this one was he wanted to sort them. He wanted to get them all in the right order. So this is when he was learning how to count. So this is just literally a toy. It's definitely worthwhile in this particular case to make absolutely sure you put it away. And so that's actually part of the life process of working out how to put things away as well when you finish playing with them. But he was delighted to put these all in order and work it out. And then he was counting them. So once we had them all, and then once you've got that, you can see the obvious next step is that what happens if you've got 2. So this goes all the way from 1 to 10. And actually turn it over. You can count the dots, I think. We know you've got the dots on the 10. You don't have the dots on the other ones, it seems. Not on this group. But there's so many things you can do with it. In other words, you've got a manipulative that no matter what operation you're working on, you've got something that you can actually work on. So you know that this is 1. So let's say you have 3 times 4, which is that 1, 2, 3, 4. Well, you very soon learn that your pink one is 4. And if you're not sure, you can get 2 of these, 2 of those, make 4. And this does it with fractions. 2 of those make 4. So 2 2s make 4. When we've got 3 times 4. All right. So that's 4. So that's 4, 8, 12. And you can, there's one of the reasons why I got this box, and I've got loads of them. You can literally have a physical representation of all the activities. So this can very well help you, even just help you learn your times table, so you can visualize. Visualizing is so important in math, so you can visualize what you're doing here. So I'm just going to put these away and see what else. We've got 10 more minutes to have a look, see what else we can play with. So this works for fractions, it works for sorting, it works for working out. It's getting your number sense, making sense of the numbers that you're looking at. So they're not just digits, but they actually have a meaning. They talk about the fiveness of 5. How big is 5? So, and you've got lots of activities here in this book. Using a meter stick for it, and then different base systems. So this one is talking about, so it's not just base 10, you've got other different bases, building and interpreting a growing pattern. Now that is something that is, pattern recognition is hugely important. So getting this book and just going through it and or picking out an activity. I mean, for young learners, just play the game. For older learners, you then take that same game and give it its significance, and this book can really help you do that. I'd really like to do something like that with Tony. What we're doing on the Aiming High website is every activity we do is something that can be used by people that can't necessarily get a resource like this in their school. So it's something you can make out of cardboard. So we have made cardboard, not rods so much, but cardboard lengths, and you use similar ideas by marking them using cardboard lengths. Now, one of the really lovely things you can do, this book is by Steve Humble. It's called How to Be Inventive When Teaching Primary Mathematics. And the lovely thing it's got in here, there's lots and lots of lovely activities. The thing I love is doing trails. Now, where was it? I've lost my spot with doing maths trails. Now, the great thing about maths trails is you can allow the learners to, where's my maths trail? You can allow the learners to create their own maths trail. Now, again, on the Aiming High website, so we've got that's gone now, but also on everything on ATM and on the Aiming High website it's all about asking questions. It's not about answering them. It's about guiding and asking questions and guiding. and encouraging, especially like in any dynamic, if you've got more than one, well, if you've got more than one person, you're going to have one leading and one following probably. You might have one that understands and one that doesn't. Well, whenever you've got the one that doesn't understand, then instead of doing it for them or helping them do it or showing them how to do it, then ask questions until they work it out for themselves. Now, this can take time, and you don't necessarily want to do it all in one session, which is the great thing about playing games. Once you've got the games, then our mathematical world, I think it must be in here actually, the very beginning, our mathematical world. Here we are, a math walk. Here he calls it a maths walk. How to plan and organize your first maths walk. Well, that's a great reason on its own to buy this book. I do have another book of his. It's all about maths walks, but I don't know where it is right now. But this one, and the great thing with this is you can get the learners to plan their own maths walk in the classroom, in their bedroom, at home, and it isn't based around doing simple things like what's 4 times 3. You can go, well, I've got 4 and the answer's 12. So what do I need to do to 4 to get an answer of 12? And there are different possibilities. So you don't want to be asking, whoopsie, that's not what I meant to do. What I meant to do is this. See my beautiful face. It's not about asking what's 3 times 4 or what's 8 plus 4. It's about that's a far richer question. I've got something, I don't know what, to do. I can do to 4 to make 12. And so there are different things you can do. I mean, one of the things you could be, it doesn't have to be time. What would you do with a divide? What would you do with a plus? What would you do with a minus? And what would you do with a multiply to make 12? What else could you possibly do? What other possibilities are there? And how many different ways can you do that? What else? What other questions can you ask? That's just an example of, you want to make it as open as possible with other possibilities, with always, well, what if, and keep the minds curious. And I've got one more book, Curious and Creative. Creativity is huge in learning, because we can't actually learn without the help of our imagination. I'm going to just show this on here. I like this one. Well, this is actually the 15-minute book of STEM, so science, technology, engineering, and mathematics. And it's just got lots of lovely ideas to get your learners enthusiastic about doing things. And then you want to be asking these open questions. Well, what if we did this, and why is this happening? And just get your learners curious and moving and becoming lifelong learners. Tony talks about, and I work with her about the spiral learning curve. And the idea is that you get on the learning curve and you keep repeating the same subject, you keep working on the same subject again and again as your education career develops. Or like myself, I became an electronic engineer, and then you don't really do any maths or anything like that for years until I decided I was on this mission, was given this mission. So then I had to not just relearn. I'm having to relearn a lot of the math that I ever did. I do not have a good memory, so I keep relearning and then forgetting again. But the other thing is, I never did learn how to help someone learn how to learn maths. I never did learn how to help someone learn maths. There is a huge difference between knowing how to do it and helping someone learn it. And the big key is asking questions and giving them the power of learning. Now, I have lost my questions. I had this, oh my goodness. Somebody help me here. Oh my, oh my, oh my. Well, I don't have my points. I had my points written down, and now I don't have my points written down. Oh, maybe they're under here, under my box. Here we go. So I don't have 10 today. I have play games. This is specifically with maths and mindset and developing a growth mindset and enjoying it, going from anxiety to enjoyment. Play games. No pressure applied, especially not if someone's already anxious or hates maths. No pressure, just play. And only for as long as they want. Especially the younger they are, the more that's going to happen. But they could be older as well and only want to do it. Be enthusiastic for a little bit, but don't do it for too long. If they become unenthusiastic, they're not going to want to do it again if they get, if it becomes a painful experience. Encourage perseverance and determination. Praise effort rather than talent. I'm going to repeat that every time you see me. Praise effort, not talent. Be not ashamed. Encourage them to be not ashamed to not know something, and that means you've got to model it. So you've got to be not ashamed to show you don't know. And if they ask you a question, it's okay to say, I don't know. Let's find out. So it's okay to not know, and it's okay. And you don't want to fear looking foolish or looking stupid, because if you don't know, you don't know. That doesn't mean you're stupid. It just means you don't know. And the wiser person is the one that is happy to find out, rather than say, I don't know, going away and not dealing with it. And you're modeling that. If you're doing that, your child is learning that. Whether you're a teacher, whether you're a parent, whether you're a grandparent or a carer, that child is learning that behavior if you're doing it. And then, be not afraid to ask, or be brave and ask. Always ask. If you don't know, ask. Thank you for joining me for today's Mindset Monday. And it's all about maths, but it's kind of hard for me if I don't have a guest. It's kind of hard for me to not talk about maths, because that's the thing I like to talk about. So Tony and I will be on in 15 minutes at 5 o'clock London time with Happy Maths Hour. Please join me for that. Thank you.